Hey everyone, welcome back. So this time we'll be talking about reactions of alcohols and thiols. If you're in the Timberlake textbook, you're in chapter 13, section 4. The Libre textbooks, you're in chapter 14, sections 5 and 11. So section 5 will be the alcohols portion. Alcohol. 1411 will be the thiol. Anyway, let's get started. Um, so the first type of reaction with alcohols we're going to cover are dehydration reactions. Dehydration reactions are kind of what they sound like. You lose water, so it's a loss of water, but you're forming a carbon-carbon double bond where the alcohol used to be. This is catalyzed by acids. A lot of times acids will just be represented as H plus, and it takes place in a heated environment. So a lot of times you'll see H plus and heat. That just means that there's an acid present and that the reaction is heated up. Now, primary alcohols only form one kind of product. So if we look at these two primary alcohols, we have ethanol on top, we have cyclopentanol on the bottom. When we add acid and heat, we form a double bond um, across the carbons involved. And so these are primary alcohols because the carbon attached to the OH is only attached to one other carbon. This carbon attached to the OH is attached to just one carbon. So you could say that it's attached to two, but because these two carbons have the same number of hydrogens, they're basically the same. So these are both primary alcohols. And when you take away the OH group, you're just forming the double bond that you see here, that you see here. Now we could have formed cyclopentene in the shape of this, but these two are equivalent structures. Uh, oh my. They're equivalent structures, meaning they're the exact same. Um, there we go. Equivalent. Now, secondary alcohols form two different products, and they follow what's known as Zaitsev's rule. Zaitsev's rule says that the hydrogen you would remove a hydrogen from the carbon with the least number of hydrogens. So let's take a look. If we have this secondary alcohol, and this is a secondary alcohol because the carbon carbon with the OH group is attached to two different carbon groups. One has one, two, three hydrogens. The other one has one, two hydrogens. So if we're following Zaitsev's rule, we add acid, we add heat, the dehydration reaction is going to remove the hydrogen from the carbon with the least number of hydrogens, or prefer to remove the hydrogen from the carbon with the least number of hydrogens. So it would prefer to remove one of these hydrogens and give you this product, 2-butene. And I'm assuming that you've already gone through alkenes, alkynes, and naming conventions with Professor Bradshaw, so you should be able to recognize this as 2-butene. But anyway, it took a hydrogen away from this carbon because it had the least number of hydrogens in the original molecule, and so this is the alkene that forms. And there's also a possibility of taking away one of these hydrogens from the carbon on the right, but that would be against Zaitsev's rule, and this would be a minor project, minor product, sorry, 1-butene. The 2-butene takes up about 90% of what you recover, The one butene is about 10%. So let's draw out some structures of dehydration reaction product. So I'm actually going to draw this. I'm actually going to draw this a little differently. I'm going to draw this as 2, 3, 4, and then OH. And then I'm going to draw out hydrogen here and hydrogen here. So when we take away the OH, take away the hydrogen, we're going to form a double bond here. So our final product should look something like this. Should look something like that. If we look at this carbon attached to the alcohol group is attached to two different carbons, right? We have one carbon, one of the carbons. So on this side, we have two hydrogens. On this side, this carbon only has one hydrogen. So this is so where the first example was a primary alcohol, this one is a secondary alcohol. So when we add heat and acid, we could form two different products, the Zaitsev product and the not anti-Zaitsev product or non-Zaitsev product. The Zaitsev rule product says that we'll remove the hydrogen from the carbon with the least number of hydrogens. So we'll remove this one first, in which case our product should look something like this with the double bond between the carbon that had the OH and the carbon with the methyl group, or we could form something that looks like this with the double bond on top. The top product would be the major product. This bottom product would be the minor product. The other type of reaction with alcohols is known as